Okay, and hello, welcome everyone to this video. So in this video, I want to discuss engineering units. It is a net standard 2.0 targeting package. And of course, it targets a lot of other frameworks as well. What it does is that it tightly integrates units with into your code so that you're forced to use the correct units. This is a great tool for engineering programs. So I want to talk about how we can use it. Okay. So the first thing first is to use this thing to add it to your .NET package. So the way to do it is this .NET add package. Okay. Make sure you have the package where your VB project is. Okay. Let's go back here. Okay. Add package engineering units. Actually, you can just copy and paste this, right? You can just copy and paste this, and you're there. Okay. So it's already added. Okay. Vim net call. Yeah, it's already added here. Okay. So it's already there. It's updated. It's updated this package, so this works perfectly fine. So that's installation, pretty straightforward. Okay, how do you use it? You need to use two namespaces here. One is called engineering units and one is called EngineeringUnits units. Okay, so let me show you where I started tinkering with this. Okay, so go to UnitTest IXML reader .visual basic. This is where I actually started playing with engineering units. Okay, for Visual Basic, you use imports. You don't use the using keyword. All right. So here's what I did with engineering units. Oops. Quit. Escape. Quit. Oh, okay. There you go. Haven't mastered Vim yet, so pardon me for that. Okay, let me close this part. I have a free terminal on the left, and I have things here to do on the right. Okay, so .NET test. Okay, so this is where I started playing with engineering units. Found it very useful. So here we go. Okay, most of the code that I'm actually doing is within this theory test right here. And you see this theory test actually just executes this test once using no input data. It is as good as a fact test. Okay, so if I replace this theory and inline data with fact, I'll get pretty much the same thing. Okay, but the theory syntax is much more valuable, so I'll just leave it as theory so that I can change this to a theory test anytime I want. So I'll go 1, 2, 3, 4. Theory. Okay, next thing, inline data, and I'll not put anything, and now I'll just do sub YouTube demo engineering units. Okay, and that's it, and sub. Okay, I'll go to top and put these two brackets here, and I'll go 5 down, go to the beginning, and I'll not execute this code. Okay, so right. So let me quickly run you through the libraries that are very important. Okay, see, everything's passed. Okay, so the libraries that are important are system, xunit for the test. If you want to run this in the app, just use system. You don't need anything else. Okay, but I'm running this as an xunit test. So this is pretty much, I mean, the way I like to fumble around with, play with code before I start. So it's like a bit, I'm using the unit test as if it were a console app, but it's not a console app. Okay, I just leave it as such. Okay, so I'm using this xunit test to test out how to do engineering units. This is my DWSim XML libraries. No need to do this. Imports engineering units. Imports EngineeringUnits.units. So this is the namespace, and this is the namespace of the tests. So that's all. Okay, so I only want you to pay attention to this bit of code here, the theory, inline data, and YouTube demo engineering units, and then end sub. Okay, so let's bring you through the basics first. Okay, how do we let's say declare temperature? So this is the most basic one. Okay, so this was very simple. Temperature, the way you declare temperature is as such. You can look at this. Temperature T1. Okay, maybe I'll not do T1. I'll saw freezing point. Water equals okay, this is the C# way of doing. Again, this is wrong. CIW_dim freezing point of water as temperature. This is Visual Basic way of doing it. And then what's next? Temperature. Okay, freezing point of water, freezing point water equals new temperature. So this is how you start making a new temperature class. And I want this to be at 0 degrees C. Okay, and then how do I the first thing you enter is a double. This should not be a string, sorry. This should be a double thing, or in other words, a number. So of course I didn't put decimal points there, but yeah. Okay, the units are here. Temperature unit degree Celsius. So okay, just follow that. Temperature unit dot degree Celsius. Okay, and I'm going to start the test to see what it looks like, if there are any errors. Okay, and of course here I misspelled temperature as usual. Okay, CIW temperature. Ooh. Okay, let me exit. I split the screen by accident. V-split terminal and quit this site. There you go. Okay, so okay, I can do a console write line of this freezing point water, and it will show us the right units. Oops. V-split terminal quit. Okay, I don't want to type the exit again. Okay, .NET test. So it will compile everything, and it will show the freezing point of water as 0 degrees C. Okay, so that's great. Okay, how about changing the units? Okay, let's say I want degree Kelvin. Okay, what are the available units? Okay, you can actually go into the GitHub. Okay, I'll show you. You can actually search. Go into base units, and you go into temperature. These are your 7 SI base units. Go into temperature enum, and you will see all the units here. Okay, what are the unit types that you will see here? One here is degree Celsius. It's spelled without the S. It's not degrees Celsius, it's degree Celsius. Okay, degree Celsius. So if you want to take a look at other units, okay, other units here are like Rankine, degree C, Kelvin, and of course you can specify SI units as well. So let me show you the way of doing it using SI units. Freezing point water equals new temperature 273.15. Okay, temperature unit dot SI. Okay, this is dealing with SI units, which will automatically default to Kelvin because Kelvin is the SI unit of temperature. You can see 273.2 Kelvin. Okay, it's a little bit off in the precision, but you know, it does the job. Okay, so this is the freezing point of water in Kelvin. All right, if you want to specify Kelvin as well, you can. You can paste here. Okay, CIW Kelvin. Okay, let's see what the spelling is. You can take a look here. It's a capital K. Okay, so let's open. Okay, it will pretty much give you the same results. Okay, 273.2 Kelvin. Yeah, so that is the basic thing of how you declare a new unit object. Okay, how do you then now change it to other kinds of things? For example, if I want it to be as a Fahrenheit or something like that, how do I do so? Okay, you can use the from method. Okay, for example here, oh no, let's see, where is it? Conversion. All right. Okay, let me show you where the conversions are. A lot of good example code you can find actually within the tests. Okay, I don't have everything offhand, as you can see. I'm still like exploring it live with you. But okay, here are the unit tests, and you can look at the unit test for temperature, and you can see a lot of example code. Okay, for example, temperature equals to new temperature unit Celsius, degree Celsius. Okay, basically they check whether two instances of the temperature are equal. Okay. All right, so let's see here. Okay, so you take a look here. Take a look here. You can use the as method if you want to convert unit. You can take a look here. Temperature unit as you, okay, if you have a temperature object, for example T1 here, you can use the as operator. As operator, then you insert the new unit that you want. Okay, so let's take a look how we do this. So I have this freezing point of water, and I should get 32 degrees Fahrenheit if I convert it to Fahrenheit. Freezing point water equals to new, or rather, freezing point water dot s, and then I have to put down here temperature unit dot degree Fahrenheit. Okay, let me open a new line and do a console write line. Freezing point water. I hope this works. Okay, let's take a look at what our results are. Okay, you need to give it a unit unless you set it to 0. Okay. Oh, temperature unit. Okay, hold on a while. It says a wrong unit exception. Oh, okay. Okay, so this is the right way to do it. Okay. Over here, okay, I actually took a good look in the unit test, and this is how it's supposed to be done. Okay, so let's take a look. Okay, this is the right code. Okay, what do? I need to find a freezing point in Fahrenheit as some sort of double. Okay, this has to be a double first. Okay, to convert, I need to convert this thing to like a double. So dim freezing point F as double. Freezing point F is here. Freezing point F equals to freezing point water. I use the as keyword, and this will return a double. Okay, it will do unit conversion. So I take this temperature object. Okay, and this temperature object called freezing point water. Freezing point water has a method called as, which will do this unit conversion. So let's say now I have the freezing point of water as 273.15. Okay, I want to convert it to degree Fahrenheit. I just use the as keyword, and I put the temperature unit. So what I'm saying here is I say freezing point water as temperature unit degree Fahrenheit. Okay, the return type of this function is a double. It is not a temperature unit. So when I do this .NET test, okay, .NET test, okay, it will confirm that this is actually a double. Okay, I see 32 here without any units. Okay, so so the way to do it is, if you want to redo this, okay, if you want to redo this, freezing point water equals to new temperature freezing point F, and I'll put a temperature unit here, temperature unit dot degree Fahrenheit. Okay, so it's conversion is all there for you. It will perform these conversions, but the type of return is a double. It is not a temperature unit. Okay, so this is how their conversion works. Okay, so this is how their conversion works. And I open console.writeLine freezing point water again. Oh, .NET test. Okay, I don't want to exit by accident again. That's a bit annoying. Okay, see, 32 degrees Fahrenheit. Okay. Okay, so not only can you convert these temperature units objects to doubles, you can also convert them to strings. Console.writeLine freezing point water. Okay, I can have a toString method. So there are two ways you can convert the thing to a double, or you can convert the thing to a string. Both of them are okay. So these things will be somewhat useful later on if you want to do some kind of comparison. So you'll see 32 degrees F being printed twice, but the first type is that you just print the object directly. The second type is that you just print it to string. Right, so that is how we do it. Okay, so unit conversions, you kind of have to declare two objects and then you put the double of one into the other. So what do I mean by this? If I have the freezing point of water here in Kelvin, okay, if I have a freezing point of water here in Kelvin, I will need to use this as the S functionality right here to change it to Fahrenheit. Okay, but the return type is double, so there's no units right here. So you will need to put this double here into making a new temperature object. Okay, and the default units will be Fahrenheit rather than Kelvin. Okay, so these are some ways you can actually make new objects and perform unit conversions. Next thing, a little bit more complicated. Okay, sometimes units are a little bit complicated. For example, if I go to the DWSim GitHub, okay, and let me go to the property package, right? Go to property package and I'll find a humongously long line of code. Okay, go to base classes. Okay, not property methods. Let's go to property packages and you will see very long classes here. Where is it? Where is it? Oh, right. I need to go to base classes. Is it property package.vb? Oh, there you are. So lots of classes right here. Okay, property packages. You import lots of things. Let's say you want to look for heat capacity. Come. Ideal gas. Oh dear, I did not ask for this. Okay, let me look again. Oh, this thing is really lagging me. That's not fun. Chromium. Okay, let me look at it again. Control-Shift-T. Yes. So this is a DWSim property package. It'll take a very long while to load because it's so long, 12,000 lines long. Okay, what are we having here? If we take a look and we try to find ideal gas. Okay. Yeah, there's a lot of things here. What I'm looking for is where they look for the ideal gas heat capacity constants. So I have things like this: ideal gas heat capacity constants. Okay, and you see this thing right here. Okay, result CP equals to A plus BT plus CT squared plus DT plus ET to the 4, where CP is in kJ per kg per mole. Ooh, these are ideal gas heat capacity units, or rather heat capacity units in general. Okay, so more complicated example. Okay, ideal gas heat capacity. So you have this sort of a setup right here. Okay, CP equals to A plus BT plus CT squared plus DT cubed plus ET to the 4. Right, this is the end result of what I'm going for, because I'll be dealing with ideal gas constants. Right, so okay, this is the this is for DWSim. This one's for ChemSep. Alright, again, no units here. I don't know what units these are. It's a little bit, yeah, I have to go and find out. But at least he put comments here, so very appreciative for that. Thank you. Okay, so let's say you have this sort of units, ideal gas heat capacity constants with the units. So you can see that this ideal gas heat capacity is in kJ per kg per mole. Okay, do we have that in EngineeringUnits? Okay. No, okay, so not necessarily. All right, not necessarily. So we need something a little bit more complicated than what we just explored briefly. Okay, so I'll stop for now because it's already 20 minutes. I will continue more in the next video.